we talked about logarithmic derivatives, the inverse of the logarithm is an exponential equation, okay? And typically we talk about exponentials before we talk about logarithms, but for derivatives we did it backwards, okay? So before we start talking about the derivatives, I want you to remember how we use the natural logs and the logarithms with our exponentials to help us solve equations. Okay, so look at this one right here. 12e to the 3x minus 2 equals 8. If we would want to solve for x, what is our first step? Okay. Okay. Then what do we do? Okay. We have a variable in our exponent. If we want to solve for it, we would need to change forms. Log base e of 8/12 equals 3x minus 2. You're going to need your calculators anyway for when we start looking at the derivatives. Okay, so what can you do? Can you put this in your calculator? And then add 2, and then divide the 3 over. So the natural log of 8/12, that's not at all what that was. Plus 2 divided by 3, you should get x is 0.532. Excellent. What? Shouldn't matter. Shouldn't. But I like your calculators to be in radian mode for when we graph anything trigonometric. Okay, on this one, we have a logarithmic equation. Okay, so we can subtract 13 over to the other side and divide that negative over. And so in this case, if we want to solve for x, again, we're switching forms, but now we're switching to exponential. So e to the negative 4 equals x. What I need you to keep in mind is that an exponential and a logarithmic are inverses of each other. A logarithm and an exponential are inverses of each other. So remember, back to your Algebra 2 days and your pre-calc days, if you compose two functions that are inverses with each other, they cancel each other out to be x. So if you have the natural log of e to the x, boom, those cancel out and you're left with x. If you have e raised to the natural log of x, boom, those cancel out, you're left with x. E to a power and natural log are inverses, they undo each other. Okay? That's not super important to understand the derivative of e to the x, but it is important as we go through some of the different types of problems. If we need to simplify something that has both e and natural log in it, we can. That is a possibility. Okay? So, before I tell you what the derivative of e to the x is, I want to show you something on your calculator. Okay? Everybody get your calculator, and I want you to graph, not that, yuck. I want you to graph e to the x. Okay. First, I want you to do this. Trace 0. Our coordinate is 0, 1, right? Trace 0, enter, and it tells you the coordinate. Now watch this. If I press second calculate, so second trace, do you see dy dx right here? I want you to hit that, and I want the derivative at 0. Interesting. What's the derivative? Okay. Let's do this. Say second trace, and let's find the derivative at 1. Hey, what's the y value at 1? What's the y value at 1? Okay, what's the derivative at 1? Interesting. Let's calculate the derivative at 2. By the way, I'm showing you an alternate from Math 8. Okay, you can graph a function and find a derivative at a point. Okay. What's the y value at x is 2? 7.389, blah, 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 blah. What's the derivative? The same. One more. E cubed. Oh, shoot. Did it happen again? The y value and the derivative are the same. Did it happen again? Heidi, are you having trouble with your calculator? Yeah, go ahead now.
I forgot to sign these.
Da 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 da! The derivative of e to the x is e to the x.
Love that.
Easiest one to remember.
That way you
No. I mean, it's, this is the definition of e. This is the definition of e. Now that you know limits, you can actually understand that a little bit better. Okay? Euler was the guy, E-U-L-E-R. Euler is the guy that discovered E, so he named it after himself. Okay. Yeah. Yeah. Okay, so this is what I like to say. The derivative is copy paste. Copy paste. Copy paste. The same thing, right? Okay, it's our copy paste derivative. Come on, I don't get to be that creative very often, so I have to take my opportunities. Okay, e to the 2x. I had a math pun this morning, a math pun cartoon in pre-calc. I have this in here. It's a good day. It's a good day. I am.
Do you have anything for BC?
No, they're taking tests. I am.
You should just write something on the board.
Okay, okay. All right, so if y equals e to the 2x, then dy dx is copy paste. Times 2, it's a composition, derivative of the inside. Well, the first part is copy paste. The chain rule still exists. Okay? Copy paste times the chain rule. Okay, copy paste times the chain rule.
Control
Wait,
Yes.
so the derivative is actually bigger than the original?
Yes. E to the x's derivative is e to the x. But as soon as you make it a composition, we have to worry about the chain rule, Alex.
Well, I was thinking the derivative would be smaller.
No, not necessarily. No, there's no hard and fast rule for that. Okay. All right, y equals e to the 2 over x. Our derivative is copy paste times, don't worry about the chain rule. What is in, sorry. Don't worry about the quotient rule. We have the chain rule. We have to worry about it. But 2 over x is the same thing as 2x to the negative first. So I'm going to think of it like that. So negative 2 times negative 1, x to the negative second. That would be your chain rule. If you want to do the quotient rule, I'm not going to stop you.
No.
But this takes a fraction of the time. But if you do the quotient rule, there's nothing wrong with it. Right? Isn't that funny? Next example. Yeah, think, right? First of all, we have a product. We have a product. So we must use the product rule. The derivative of the first times the second plus the first times the derivative of the second. So e to the x squared, we have copy paste times chain rule. 2x. Oh, so painful.
Yes.
You guys are whining. Yeah, it's not that bad. It's not that bad. Okay, would you like a more intense example?
No.
Is that what you're asking? Okay.
I like these chain
I was ready for you.
I'm going to support you, even though you obviously have this.
Write it down. Okay, so you're right. We have a product that involves some compositions. Okay? So let's worry about, here I'm even going to color code. How's that? Okay? So our derivative. Okay, and if you like, let's see if I can do this. We have f prime times g plus f g prime. Some of you like to write that out. That's fine if you need to write that out. Okay? So, derivative of the first function. Copy paste. Times 9. I'm going to write now out in front because that just feels more natural. Okay? Times the second function plus our first function times the derivative of our second function. Our second function is a cosine. What's the derivative of cosine? Ooh, that was good. Keep the inside the same times 4x cubed would be good. Okay, see, that wasn't so bad. Just take your time. What rules do we need to use? Okay. I'm going to give you 20 seconds because that's all you need. I haven't started my timer yet, so be writing this down. You have 20 seconds to take this derivative because I think that's even more than you need. Hmm? Xander, what do we have?
Copy, paste and then you would find the derivative of x squared plus x minus 1, which is plus.
Excellent. There it is. That's your derivative. Easy peasy. Okay. What happens if your base is not E? Not quite. What happens if your base is not E? You still have copy paste, but much like yesterday, we need the natural log of the base multiplied to it. This is a rule. Like that could be on a rule quiz. Copy paste, natural log of the base. It even rhymes almost. Copy paste times natural log of the base. Whatever. We haven't got 40, correct?
Right.
Okay. So 3 to the x. Copy paste, natural log of the base. Yeah. Some of you are like, man, this isn't so bad. Practice it, otherwise you're not going to remember it. Now if our function is 3 to the 3x, if our function is 3 to the 3x, copy paste, natural log of the base, times, chain rule 3, because that's the derivative of the inside. Okay, I have some things on the next slide, but I just want you to drop your pencils. We're just going to relax. You're just going to watch me talk about some stuff. Okay? I have 4 different equations up here. Okay? Not that one. E to the x, 3 to the x to the e, x to the x. What's the derivative of e to the x?
Yes.
What's the derivative of 3 to the x? We mumbled it, but we got it. Okay? X to the e. That's a polynomial where we would have to use the power rule. I want you to notice that when x is in the exponent, we have an exponential and we have to use the copy-paste rules. But if x is our base and we have a numeric exponent, then we have the power rule. Do you see that? Oh my gosh, what if you have x to the x? Oh. You would have to use logarithmic differentiation to find it. Okay? Don't worry about that. Okay? Do your homework. We'll see you tomorrow. Ew.
I am about to head out.
You're not gonna do homework? You will. You can't. Sandwiches. Oh. Who are you making sandwiches for?